This problem says, for each problem, find the volume of the solid that results when the region enclosed by the curve is revolved around the x-axis. The second problem is y equals 2x plus 2 and y equals x squared plus 2. So when it says it's revolved around the x-axis, it's basically this is going around the circle. So it's creating a bunch of different circles. But the important thing here is that it's going to be basically cut out at a certain point. So let's look, for example, at a point like right here. We can see that there's another circle that will go around that won't be included. So the only parts that will be included is all of this right here. Thus, we can say that the area is equal to, we can call this function f of x and this function g of x, and we can say the area is equal to pi times f of x squared minus, because minus is this area that is not including any area for our volume. So we can do that minus pi times g of x squared. Thus, it's only a matter from there of finding the integral of the range of 0 to 2, as we can see in the graph. So 0 to 2. So then we can find the integral of this function, pi f of x g of x. So let's do that. F of x is equal to y equals 2x plus 2. Let's simplify this down and we can get pi of 2x plus 2 squared, which is going to be equal to pi of 2x plus 2 times 2x plus 2. We're factoring this out now because it will make it easier in the rest of the problem. So we can take this a step further and do pi of 4x squared plus 8x plus 4. And then we can also find g of x. So g of x is equal to y equals x squared plus 2. And for g of x, all we have to do is, we'll do the same thing to simplify the next step of the process down a little bit because it's squared. So we'll get pi times x squared plus 2 times x squared plus 2. From this, we get pi times x to the 4th plus 4x squared plus 4. So then we can plug this back into the equation here, and we will get, we'll basically do this. We'll get pi times 4x squared plus 8x plus 4, which is what we found down below. Subtract this, because this is an area that will not be included, from pi of x to the 4th plus 4x squared plus 4 dx. We have to remember the dx. So then I'll clear up some room. So basically from here, we can factor out a pi, because pi is on both sides. So it's pi here and pi here. So we can just do pi, factor it out, and we'll get the integral of 0 to 2 of 4x squared plus 8x plus 4. We'll distribute the negative sign and we'll get negative x to the 4th plus 4x squared plus 4. And this is all times dx. So the next step will be to take the integral, but we can see that we could actually make this simpler on ourselves because, this is actually negative 4x. These can actually, and this is actually negative 4. These can actually take away some of the values because negative 4 plus 4 is, they cancel each other out. And then negative 4x squared plus 4x squared is also, they cancel each other out. So that means we're left with pi times the integral of 0 to 2 of negative x to the 4th plus 8x, all times dx. So from this is just a simple integral that we can solve by finding the antiderivatives. We do x to the 5th divided by 5 plus 8 divided by 2x squared. This is evaluated from 0 to 2. Then we can evaluate it at 2, and we get negative x to the fifth. So 2 to the fifth is 2, 4, 8, 16, 32. Negative 32 over 5 plus this 8 divided by 2 is 4. So times 4x squared, which is equal to 16. 16 is equal to 80 over 5. This will make it easier for our next step. And then we can see we'll do minus evaluated at 0, but 0 to the fifth is just 0, and 0 squared is also just 0. So we'll see it's just minus 0. So our next step, we'll just move it over here, is to simplify now. So this is equal to pi times negative 32 over 5 plus 80 over 5. This just simplifies to 48 over 5. And then we simplify further. We get 48 over pi, 48 times pi over 5. And this is approximately equal to 30.159. And that is our answer.